based on the experimental evidence done by many researchers on beams reinforced with GFRP bars, and others did test on slabs reinforced with GFRP bars. They find that the GFRP reinforced concrete structures are able to resist fire for 130 minutes, which exceeds the 2 hours. As you know, in steel we have a limit of 2 hours for fire endurance. In FRB also we found that the structure is able to resist after 130 minutes. So FRB bars are able to resist the heat as steel, but after 2 hours, the capacity, the member cannot be able to resist any loads more. So it is like steel. In fire, for steel, we have 2 hours, and after that, we have a complete collapse from the building. In GFRB, we have 130 minutes. We are in our company, we are producing GFRB materials, CFRB materials, and basalt FRB bars. No problem, we can produce any FRB material. But really, as I said in my presentation, we are focusing on the GFRB bars due to their cost effectiveness than other types of FRB bars. And also based on the experimental work and the field application, GFRB bars as a reinforcing material showed a good performance with many applications like bridges, culverts, and ICF walls also. The FRB bars generally cannot be bended. We cannot bend the GFRB bar, okay, or any FRB bar, but we can give you an efficient solution to do that. If we have a straight bar like this one, and we have a straight bar like this one, if we will connect them with a connector in the corner, so we cannot bend it, but we can connect it with a connector in the corner, so it will be easier for you and for the people who are working in this field to get the bar bended in many locations. He can do this if he would like to cut these bars like 5 meters or half meter or something like this, so it will save also in the quantity of FRB bars used in the project. For sure, yes, because for FRB bars, generally, you need to know the elastic modulus of the FRB bar. You need to know the tensile modulus, the tensile strength, sorry. You need to know the tensile strain, okay? So you will use these informations to the design, as I mentioned in the presentation. So if you will replace GFRB with CFRB, it will be the same. But the calculations will give you different capacities for the design section, because the mechanical properties of the GFRB bars and the other types are different. The design should be safe and economic. So we can't ignore the economic issue from the design. So people now are targeting the GFRB materials over the other types of FRB due to their cost effectiveness and their performance. The performance of GFRB bars, it is very close, you know, to the CFRB. It is not the same, but it's very close. In terms of cost, GFRB will be more economical. You know, in the current Canadian standard, 823.3 and the American code ACI 318 for steel reinforced concrete structures. They allow using the flat plate system in the region of high seismicity as a gravity force resisting system only. So we are using the flat plate structure as a structure, as a gravity force resisting system. In this case, a special moment frame or shear walls can be provided as the main seismic force resisting system. So in seismic zones, we need to include shear walls in our building in order to resist the seismic forces. Okay, but also we need to consider that the connection between the column and the slab um, should have a minimum level of ductility. In FRB, we don't have term called ductility as a steel. We have term called durability. So I will give you an example. We have experimental study for GFRB edge slab column connections under cyclic loading. Based on that, they get one connection with steel and the other with FRB, and they tested them under a cyclic loading. The GFRB connections was able to sustain like 2.5% drift ratio, which is higher than the 1.5 minimum drift ratio for steel. So by using FRB bars as the same reinforcement ratio like steel bars, you will get 2.5. You will get more drift capacity for the connection. So you will accommodate the condition of deformability. In other words, ductility in steel codes. The GFRB connections, I mean here by connection, the connection between the slab and the column, we call it the slab column connection, is able to undergo the exceeded seismic drift while maintaining their gravity load carrying capacity.